Welcome back to Edupedia world. Last lecture we discussed the fundamentals of current, potential and potential difference. Today we will continue from this there and we will discuss the concept of resistance. We will see the reason for resistance and the factors which affect resistance. Then we will jump into one of the most popular laws in current electricity, that is Ohm's Law. We will see what it is and condition when Ohm's Law kind of breaks down. What is the validity of Ohm's Law? So let's start with discussing resistance. When current flows through a wire, then the wire offers obstruction or resistance to the movement of its charged particles. In the case of a conductor, that is electrons. So this obstruction offered to the flow of electrons or the flow of current in general is called resistance. The resistance is obstruction to the flow of current. Well enough, we see that there is a resistance offered to the flow of current, but why is there a presence of resistance? To understand that, let's see what exactly is happening inside a wire. A wire, current carrying wire, will have positively charged ions which are not free to move, but they are dispersed throughout. I will just draw a few of them, and negatively charged electrons which are free to move, right? Now suppose you apply a potential difference, that is you attach a battery to the wire. This is the symbol of a battery, okay, and this means the longer line means the positive terminal of the battery, and the smaller line means the negative terminal of the battery. So this end, that is this position, will be at higher potential and this position will be at lower potential, okay. That means this is lower potential, this is higher potential. As a result, electrons will try to flow from this direction to this direction, and current will flow from higher potential to lower potential. So this is the representation shown in the diagram. Now as the battery is applied, there is a potential difference generated and the charges will try to move. The ions, the positive ions, would like to move from higher potential to lower potential, that is in this direction, but since they are not free to move, they will stay in their position. But the electrons that are free to move will move from the negative terminal to the positive terminal, okay. And there are many ions and there are many free electrons. So these electrons will move in this direction, and due to the potential difference, what will happen? The electrons will start speeding up. But in the course of its movement from this end to this end, what will happen? The electrons will encounter other electrons, but more importantly, they will also encounter these positive ions, right? And since they are stagnant and they are much heavier than the electrons, suppose here is a positive ion, then this electron on striking this will slow down, right, and may temporarily stop, and then it has to restart again its motion towards the positive terminal. Therefore what we see is that the electrons, due to the potential difference, is starting to speed up, but due to the ions present which are immovable, they keep slowing down. And as a result, what will happen is that the electrons will move from negative terminal to positive terminal, but at a much moderate speed due to constant collision with the ions. And this is the fundamental reason why the resistance is there in a wire. These ions offer the resistance to the motion. Okay. Now that we have understood the concept, the physical reason behind the resistance, let us see the factors which will affect the resistance. The factors that will affect the resistance is, one, the nature of the conductor. Nature of conductor. What do I mean by the nature of conductor? The nature of the conductor basically defines what material the wire is made out of. There are some materials which offer a lot of resistance. There are other materials which offer very less resistance. And depending on how much resistance they offer, the materials are termed as either conductor, they offer less resistance, semiconductor, they offer intermediate resistance, or insulator. They try to block out the movement completely, so they have very high resistance. Now even in conductor, depending on which metal we are exactly using, the amount of resistance can be very low or relatively low. So it is a material property, to be precise. Second, given we have two wires of same material but different length, then they too will have different resistance. Why? Let's assume there is a wire of length, say this much, and then there is a wire of length, say this much. So since this is the longer wire, everything else is the same, material is same, the cross section is same, but this wire is long wire, so electrons will have to face a lot more resistance in this longer wire than this wire to travel from one end to another. So what we can say is resistance is directly proportional to the length of the wire. Longer the length, higher is the resistance. Third factor is thickness of the conductor, or area of cross section. To understand this, let us see the example of two wires, one having a thin cross section, something like this, and another wire we have of thicker cross section but same material and same length. What will happen is that this thinner wire offers less area for the electrons to move from the one end to another end, whereas the thicker wire will offer a larger area for the electron to move. Therefore, the electron has easier access from one end to other end in the case of thicker wire compared to the thinner wire. Therefore, we can say that resistance is inversely proportional to the area of cross section. Let me write it by a capital A. So larger is the area of cross section, less is the resistance, as we have seen here. Fine. Now the final condition is the temperature of the conductor. Temperature of conductor. Okay, so what happens is that the amount of resistance offered by a material depends on the temperature of the conductor also. How come? When the temperature of the conductor is increased, the vibration of the ions increases from its mean position. As a result, what will happen is that they will effectively block more area of cross section, right? and therefore with increasing temperature resistance will increase. I hope you understand the idea that though these ions are fixed, but they have a vibration of their own, right? And as the temperature increases, the vibration increases, they block more path. They block more path and resistance increases. So resistance is directly proportional, maybe not directly proportional, but resistance, let's say this way, resistance increases as temperature increases. There may not be a linear relation, but with increasing temperature resistance increases. Fine. We have understood the concept of resistance, and we have seen the different parameters on which the resistance of a wire, conducting wire, would depend. Now with this background, let us see the second part of discussion of today's class, which is known as Ohm's Law. This is probably one of the most heard law in physics, maybe similar to Newton's laws of motion. So what exactly does Ohm law state? Ohm's law basically correlates the amount of current that can flow through a wire, the potential difference, that is the potential difference applied, and the resistance of the body. Okay, so the three parameters Ohm's law, the three parameters that Ohm's law will relate are: one is current, second is potential difference, and third is resistance. Current denoted by I, potential difference denoted by capital V, and resistance denoted by a capital R. And Ohm's law is written as V is equal to I times R. Okay, so what Ohm's law states is that the current flowing through a conductor is directly proportional to the potential difference that we apply across the ends. So higher is the potential difference across the end, more will the current flow through the conductor for the same resistance, right? Now to keep the same resistance, what has to be taken care? The physical dimensions has to remain constant throughout. The nature of the conductor, obviously the conductor we cannot change, and also the temperature condition needs to be maintained. Then the resistance remain constant, and under such circumstances the current flowing is directly proportional to the potential difference applied, and that is precisely the Ohm's law. Okay, now let's see what is the units of resistance. So the units of resistance can be seen if we write resistance in terms of potential upon current. A potential is defined by volt and current is defined by coulomb, rather ampere. Okay, so resistance, unit of resistance is volt per ampere. This unit is in terms of the properties that define resistance, but this volt per ampere is alternatively written as ohm, O-H-M. Okay, so the more popular unit for resistance is ohm, but ohm is exactly same as volt per ampere. So what is ohm? Ohm is the resistance of a conductor can be said to be 1 ohm. The current flowing through a wire is 1 ampere given a potential difference of 1 volt is applied across it. In other words, when 1 volt potential difference results in a current flow of 1 ampere, then the resistance of the wire is said to be 1 ohm. Okay. There are some higher units of resistance. One is kilo ohm. One thing I forgot to mention, that ohm is denoted by this symbol. So kilo ohm is 10 to the power 3 ohm. Then we have mega ohm, that would be 10 to the power 6 ohms. So these are higher units, but you need to remember mainly ohm and kilo ohm. This will keep on coming back. Fine. So now we have seen what is resistance. We have seen the Ohm's law and how potential correlates with resistance and current. Now let us understand another terminology which is known as conductance. Conductance. What is conductance? Conductance is 1 upon resistance. So the reciprocal of resistance is known as conductance. Physically, what that would mean is that a material with high conductance offers less resistance for the electrons to flow, or in other words, a material with high conductance allows easy conductivity, thereby the name conductance. What will be the units? The units would be inverse of ohm, that is ohm inverse, or the popular unit which is equivalent to ohm inverse is called Siemens. S-I-E-M-E-N, Siemens. Fine. Now we know the idea of resistance. Also we have seen what is conductance. Let us see a plot for the Ohm's law. What do I mean by a plot? I will come to it in a minute. Suppose we do an experiment, and in that experiment what we do is that we measure the amount of current flowing at different potential. We fix a resistance, we change the potential, and we measure how much current is flowing for each potential, and if we plot those values, right, what will happen is that we will find them falling on a straight line. Okay, and this experiment is verification of the Ohm's law, because Ohm's law shows that the potential and current should be linearly related, and this experiment of varying current with varying potential will result in a linear relation with the slope equal to resistance. So this slope will be our resistance. Fine. This is basic experimental proof of Ohm's law. Now suppose a scenario where we have a wire, and this is our V versus I plot. Then we increase the temperature, and then we plot the V versus I again. What we will see is now that the slope has increased. So this slope has become now R2, and this has increased. So basically with increasing temperature the slope increases. Why so? Because what we have seen here, with increasing temperature resistance increases, therefore the slope has to increase. This is T2, this is T1, and T2 is greater than T1. Therefore this is one experimental proof of Ohm's law. Second, a proof that with increasing temperature the resistance increases. Okay. Now one of the limitations of Ohm's law, as we have already mentioned and as we can see from here, is that the temperature needs to remain constant for the Ohm's law to be valid. It fails if the temperature changes. Suppose we took a measurement at T1 temperature and we plotted here, another at T1 plotted here, and another at T2 and plotted here, and then we say they are not linear, that is not going to work, because we have changed the resistance by changing the temperature. Fine, we have discussed a lot in today's class. It's better that you maybe see the video lecture again, or maybe read through theory once to concrete the whole discussion in today's lecture. Next class we will discuss what is known as a ohmic and a non-ohmic resistor. Then we will see some idea about what are superconductors, and to close the chapter we will see specific resistance or resistivity of a material. Till next class, have a great day. Goodbye.